All right, in the next part of this video, we're going to look at a 2D plane stress case in ANSYS, and we're going to extract the stress results, and we'll calculate the principal stresses by hand and compare it to the model results. So I have here in ANSYS set up a static structural analysis, and there's actually two here. So in ANSYS, you can actually set up two different load cases for the same geometry and the same meshed model. And I'll open that up. And I'm not going to go through how to run that detail by detail. I may do that in another video. But for this video, we're going to look at the load cases. I'll go over how I loaded it and the boundary conditions. So in the first load case, this is a plate, a 1" by 1" plate that's 0.125 inches thick. And I've loaded it in the vertical direction with a 100-pound force. And I've extracted some nodal results. So for this example, I'm going to look at the node in the middle of the part as defined by the global coordinate system. And I'll look at the stress state at that node. So we can go in and we can look at the stress acting in the y direction. And we see here that it's 815.1 psi on that node. And we can look at the stress in the x direction, 12.785 psi. And the normal stress in the z direction is 0. And again, that's because we're looking at a plane stress case. And the maximum principal stress, according to ANSYS, is 815.1. And the minimum, which in this case is going to be the middle principal stress, is 12.785. And the shear stress is pretty much 0 in this case. And you can also look in ANSYS, if you right-click on solution, you can insert stress. If you click vector principal, we'll actually show you your principal stress vectors. So in this case, the principal stress is in the y direction, as defined by the vector in the y direction. And now we'll look at, we'll plug these in, we'll plug those values. I've already done this, but I plugged the values from the ANSYS model into our 2D stress tensor matrix. So the stress, the normal stress in the y direction, or the y normal stress rather, is 815.1 psi, and the normal x stress was 12.8 psi. And I've calculated that. The maximum principal stress is 815.1, and the minimum is 12.8. And the max shear stress is 401.15 psi. And I've calculated the angle theta that you'd have to rotate the base coordinate system into to align with the maximum principal stress coordinate systems. And that is just 0 degrees. And that agrees well with the model. So our eigenvectors are 1, 0, 0, 1. And if we go back to our model, we'll see that the principal stress that ANSYS is showing appears to be 1, 0, and 0, 1. And if we want to verify some other results, we can, well, we'll see that we saw that our maximum principal stress was 815.1, which is what I calculated by hand. And we can also look at the max shear stress. So maximum shear, and I've defined the node as a name selection. And we'll retrieve that result. And we get 407.55. And we calculated the maximum shear stress as 401.15. So it's a little bit off from the ANSYS results. But we did confirm that our max principal stress was 815.1 and the minimum was 12.8. And again, if we look at the model, we see that the max principal stress from the model is 815.1 and the minimum principal stress is 12.785. And in the 2D case, this what's they're calling the middle would be the minimum. And you can see here that it's this other principal stress is 0, which we would expect. And now I've done another load case. So in ANSYS, you can do multiple load cases separately and superimpose them. And so for this load case, I've shown a force in the x direction acting on this face here. And I've used ANSYS to calculate or post-process the maximum principal stress and the normal stresses. So we'll look at the normal stress in the y direction, and that is minus 25.173. Again, the z normal stress and the z-axis is 0, and the x normal stress is 378.7. So I've done the calculations again for this stress case. Here you see the x stress is 370.7, the y is minus 250 or minus 25.2, and the shear stress from the model was 598.07, and I've rounded to the nearest 10th decimal place. And we calculate by hand that the max principal stress is 808 psi, and the minimum principal stress is minus 454.5. And if we go to our model, we see the max principal stress is 808.01, and the minimum principal stress is minus 454.48. And that agrees with our hand calc, which we would expect. And now I've calculated the direction that you'd have to rotate the original ANSYS system into align with the principal stress direction. And that angle would be 35.67. So it would be kind of it would be a axis direction shown here in the red. And if we look at the vector principal result, we'll see that that appears to be pretty close. Now, and then lastly, what I'll show is that you can do a linear combination in ANSYS, where you combine the stress results. And this is good for running if you have different load cases. Let's say you had a part that had various loadings on it over time, and you wanted to calculate those individual stress states. Rather than run an ANSYS for every one of those, you can calculate unit loads and then run the results by nodal superposition. So for our node, what I've done is